Good day, viewers. My name is Israel Maponda. I'm going to be taking you through Engineering Science N1. And our topic today is the particle structure of matter. And my outcomes are as follows. On number one, I've got the definition of matter. And I'll talk about the phases of matter, the properties of each phase, that is the properties of liquids, properties of solids, the properties of gases. And I'll conclude by talking about the physical change conditions. And like I said, I'm going to first define matter. Matter is defined as anything that occupies space or has volume and is made up of particles. So there are two important concepts there. Matter must occupy space. It must be made of particles. That's matter for you. Anything that is made of particles and occupies space. Now, around us, we see stones, we see trees, we see water, we see those things that we see. They are actually can be categorized into these three states of matter. And our three states of matter or phases of matter are solids, liquids, and gases. Solids, liquids, and gases. Now, each of these states has got its own properties. So I'm going now to explain the properties of each of these states. I'll start with solids. All solids have the following. They have a definite shape. You have a definite volume. Solids, particles vibrate about fixed positions, which is why solids, of course, will have, a particular shape. Uh, Particles have very little energy, but nonetheless, the particles are moving. Okay, then just to give you an idea of the particulate nature, we have solid particles. Probably they could be expressed or explained using these small dots there that will be representing the different solid particles, showing that there is actually no spaces between the solid particles. So this would mean that is a solid, and these are solid particles. Right? Then we have the liquids. Liquids have a shape. And they actually they take the shape of the container, which means if you put them in something conical, they become conical shape. If you put them in something that is cylinder, they become cylindrically shaped, circular, and so forth. Uh, they do have, of course, a definite volume. They have a definite volume. They have more energy. The particles have more energy than in solids. I was talking about solids earlier. Alright. So because these particles have got more energy, the particles can slip over each other. The particles can slip over each other, which is why solids take the shape of the container. And another property is that the particles are affected by gravity. Particles are affected by gravity, which is why most liquids, when you put them in a container, you would find that in a container they kind of form a shape which shows something that we call the meniscus. Most of the particles will be reacting to the gravity, but then because maybe in a container like glass, they will be having attractive forces between the glass walls and the particles themselves, but the rest of the particles will be pulled by the force of gravity, which I'll put, say, Fg, causing the liquid then to take the particular shape or to show this, what we call the meniscus. Okay? That's what solids do. Well, like I said, they can slip over each other, but then they show this particular property. Right. Finally, I'm going to talk about gas properties. Gases. These ones have no definite shape, no definite shape. You have no definite volume. Now, let me explain this part which says they have no definite volume. They fill the amount of space of container into which they are captured. So, like I said, they have no definite shape, they have no definite volume. They fill the amount of space of container into which they are captured. You put them in a small bottle, they fill it up. You fill them in a big container, they fill it up. The reason they do that is that gas particles are further apart from each other. Gas particles are very further apart from each other. Another thing is that they have a lot of kinetic energy. They have a lot of kinetic energy, which is why at one point one gas particle is here, at other point is there, and because of this, these gas particles, they can therefore can be compressed. They can be compressed. This is some of the properties that we see with our gas particles. All right. So from there now, let's look at some physical change conditions that can take place with these gas particles. Most of us have seen water in its ice form. We have seen water in its vapor form. We also have seen water in its liquid form. So it can assume all these phases. And that I'll explain under the physical change conditions. Right, I have got here a solid, right? Or let me put them as solids. And then I've got liquids. And then finally I've got gases. Right. If you take a gas, for example, and you cool it, remove heat from it, the gas will condense and move to become a liquid. So if you remove heat, the process which we call condensation, the gas or vapor will change from its phase to that of a liquid. That process is known as a condensation or liquefaction process. These two words can be used, liquefaction. So you can turn water vapor through that process into a liquid. But when we take in the season that is coming in summer, some people can't take in tap water, so they need to put it in the fridge. If you freeze the water, this is also a process of removing heat. If you remove the heat, the water freezes to turn into a solid. So that term which talks about changing of liquid to solid is freezing. Alright? Now, let's say now we've got ice into which we're adding heat. So this side I'm now adding heat. When you add heat on the other side, the ice or liquid will turn into the solid will turn into a liquid. And that process is called melting. I'm going to define these terms: condensation, melting, boiling, stuff like that. And if you also continue to add heat to that liquid, the liquid, through the process of adding of heat, it will turn into a gas or vapor. And this is a process known as evaporation. Evaporation. So evaporation is a process where a liquid turns into gas. Melting becomes a process where solids turn into liquids. Whereas condensation is a process where gases turn into liquids, whereas freezing is when the liquids turn into solids. Now, needless to say, there are some substances that when you kind of heat them or cool them, they simply change from a gas to from a solid. Let me use this one. From a solid to a gas, straight, without undergoing the liquid phase. An example of this is iodine. Iodine, if you heat it, it turns straight into that brown solid to a brown gas. Now, also, other substances, when they change from gas straight into a solid, this happens when you cool them, right? Through cooling or removing of heat. This is also happening. This happens only when you do this process of adding heat. Now, there is a term that we use for these two processes. That term is given this name here: sublimation. Sublimation. Substance that turn from either solid to gases or from gases to liquids directly are known as sublimates. They sublimate. Okay, viewers, today my lesson will end there. I will take you for other lessons where we are going to actually look at the particles. Like I said to you, that matter was made of particles. We're going to go into detail and look at the smallest particle of matter, and so forth and so on. Thank you so much.